Hi everyone, we're doing Unit 7B and this is Topic 3. And we should have already done Topics 1 and 2 and taken a small quiz on Topics 1 and 2 so you are prepared to start Topic 3. So Topic 3 is about exponential growth and decay, but we are doing applications. And anytime in math that you see that word applications, it really means basically that we're going to apply this problem to a real life scenario. So before we do that, there's some prerequisite skills that we need to review. And that is just how to convert back and forth between a number that's written as a percentage, as a decimal, and as a fraction. And we need to be comfortable converting between these three types of numbers, because they all are equivalent if you do it correctly. So this first box, we're going to try to fill this in. So if you have a percentage of 98, so imagine you're taking a quiz or a test and you get a 98%. Let's first write what that means as a fraction. That means 98 over 100. It means that hypothetically if you took a test with 100 questions, you would have got 98 of them correct. How to turn this into a decimal? Directly into your calculator, you can type this in. You can do 98 divided by 100, and you should get 0.98. But there is a pattern that we're going to pay attention to, and that's that if we look at your percentage, the original percentage, and our percentage is 98, if this percentage has a decimal point, it would be at the very end, and 0.98 is always going to be that decimal moved 2 spaces to the left. So imagine the decimal was here, it would be moved 2. And that's just because that's a math trick for dividing by 100. It actually just moves the place setting 2 spaces to the left. Alright, so we're going to try another one, 7%. I'm going to first do the fraction, 7 over 100. And again, you can type this directly into your calculator, 7 divided by 100. And you'll get 0.07. This 0 is incredibly important right here. If you excluded that 0, you would have an incorrect answer. Alright, the next one, 0.08. Alright, so this is in the 100th place of my decimal point. That means that is 8 over 100, and we know that that is 8%. Alright, let's do 100 next. If you get 100% in an exam, you better be very happy. That means you get 100 out of 100 points correct. And that, as a decimal, 100 divided by 100 is just 1. Alright, 0.12. This is, again, 2 decimal places. That means it's in the 100th place, 12 over 100. And that means 12%. Alright, a couple more here, 25%. We know that means 25 over 100, and that's 0.25. And lastly, 89 of 100 is 89%. That's 0.89. You know, some students take this for granted and they think that they understand this skill and they rush, and very often mistakes happen. A very common mistake that happens is looking back at this example, 7%. Very commonly, students write that that is 0.7 and that's incorrect. So if you ever are not sure, write the percentage as a fraction and do this division problem, 7 divided by 100. Alright. So next problem, we are going to look at this application equation. And this application equation, we are just going to define what the parts of it are. So exponential growth, this means any sort of real life scenario that we start with a value and that value is growing. And if we have that scenario, we're going to use this equation to describe it. So first, this a value out front has meant the same thing that it means all units. And that is the y-intercept. The y-int for intercept. And I'm going to write underneath it, the y-intercept can also be referred to as the initial value or the start. Alright, the next thing is the r, and the r is this number right here. It's inside the parentheses, it is added to the number 1. And the r stands for the percent of increase written as a decimal. I'm going to put an example here, the famous example from above. What that means is, for example, if you have 7%, and we'll say 7% growth, that means you have 0.07. That is your R. Lastly, x, that is my exponent up here, and the x is the amount of time since our initial value. And usually that time is measured in years. Okay, so our first example is a scenario. This is a true scenario about Framingham, the town we live in, and it's about Framingham in the year 2000. So one key thing so far that I think we know is that the year 2000 is our initial year. And in the year 2000, there were 66,910 people living in Framingham, and that number of people was growing by 2.1%. So the first thing this question says, what is the percent of increase? That's this number right here, 2.1%. And it says, what is this percent written as a fraction? So as a fraction, we just practice this, 2.1 over 100. What is that written as a decimal? As a decimal, we would divide 2.1 divided by 100, and we get 0.021. Next, it says if 2000 is the initial year, what is the initial value? And that's this number right here, 66,910 people. Okay, next, write an exponential function. So an exponential function is when I'm going to use what I wrote at the top. I'm still going to start with y equals, instead of a, I'm going to use my y-intercept, or my initial value, that's 66,910. And then in parentheses, 1 plus 0.021, close parentheses. 0.021 came from my r, written as a decimal. I'll highlight this for you. 66,910 came from my initial value. And then lastly, the exponent would be the letter x. We put an x right there. This is our exponential function. Next, it asks, what will the population be of Framingham in 2020? So first I have to look at this 2020, and our x right here comes from how many years or how much time since our initial value. We started recording population in 2000. 2020 is 20 years since 2000. So this 20 is going to be our x. So we're going to plug that in. So the population will be 66,910, parentheses 1 plus 0.021, and as an exponent, I'm going to plug in 20. Now make sure that you carefully plug this into your calculator. I plug it directly into my calculator. I do 66,910. I use the parenthesis function on my calculator, and then I plug in 1 plus 0.021. I use the caret symbol, like that, to get my 20. And when you do that, you should get 101,392. You actually get a decimal 0.5. But we're talking about a population here, and that's people. And you can't have 0.5 or a fraction of a person. So I'm just going to leave that as a whole number, my answer. All right, this says, what was the population in Framingham in 1995? So basically, we started recording the population in 2000. That means that 1995 is 5 years before 2000. That actually means we have to go backwards in time, and it means I'm going to use the value of -5 when I plug this into my calculator. So I'm going to plug it in exactly like I did before. 66,910, parentheses 1 plus 0.021, and then I'm going to use the caret symbol on my calculator to get an exponent of -5. I'm going to plug that in. And when you plug this into your calculator, you should get the answer, 60,306, and I'll write people there. All right, lastly, this question says, how can we tell that the function from part C will model exponential growth? And the key there is that the value in parentheses is bigger than 1. And we'll see why that makes a difference in our next problem. Alright, we turn the page, we're starting the next problem, and actually I'm not going to fill in this part. I think that you should in your notebooks, but A and R and X mean exactly the same thing as we described in our last page of notes, so you can copy those down. Alright, the next problem says Miss Henry wants to buy a used car that cost $11,800. The expected depreciation of the car is 20%. Depreciation means decay. It means the car is losing value. And then it says it's losing value 20% per year. First question, what is the percent of decrease? We know that it's 20% decrease. It says, what is the percent of decrease written as a fraction? That's 20 divided by 100. And it also says as a decimal, that's 0.2. What is the initial value? This is the initial price that Miss Henry paid, and that is $11,800. Write an exponential function to model this car's value. So since we're using depreciation or decay, I'm going to use this function up here. Y equals $11,800 goes first. That's my y-intercept. 1 minus 0.2. That came from this number right here. Close parentheses, and then I use an x. This is the function that I'm going to use to figure out the car's value at any amount of time. The first question says, how much will the car be worth in 6 years? And basically that just means I plug in a 6 for x. So I'm going to get y equals 11,800 parentheses 1 minus 0.2, and instead of x, I'm going to use the number 6. And I'm going to plug that into my calculator carefully, paying attention to the parentheses. When I do that, I get the answer of $3,093, and we'll say 29 cents. Actually, I should round 29 cents correctly to 30 cents, because I get 2,992. So that means that after 6 years, Miss Henry's $11,800 car will only be worth $3,093. The next question says, how much was the car worth 5 years ago? And this is another one going back in time. 5 years ago means before she bought it. And since we're talking about before she bought it, we're going to use -5. We're going to plug in -5 for x. So I should plug this into my calculator. 11,800, 1 minus 0.2. And as an exponent, I will plug in -5. When I plug that in carefully, I get $36,010.74. That car was worth a lot more money 5 years ago.